Good morning, good afternoon, good evening. Welcome to my class. Today we are going to discuss probability. It is a very tough topic. So most of you actually shy away from this topic. I've seen that many of the students will leave a question on probability, right? There are some reasons. So, if you are watching this video, my recommendation to you, first of all, kindly watch our set theory video. Yes, set theory really is important for probability, right? And secondly, please do watch permutations and combinations before watching this video, right? Reason is obvious. I must tell you, you cannot go without you cannot do probability without having a knowledge of set theory and permutation combination. That's for sure. All right. So when we talk about what exactly probability is, probability basically means chances, right? What is the probability of India winning? So what are the chances of India winning, right? So if you are comfortable with this, I think there are few issues that you may get rid of. First of all, set theory will tell you how the formulas are formed. For probability, and permutation and combination would be the base of probability. So that also is important, and where to use multiplication and where to use addition is something you should actually be good at. So let's start. He says, what is probability of event A? Probability of happening of event A is denoted as P of A. Alright, is denoted as P of A, probability of happening of event. It's actually equal to number of cases favorable to A upon number of cases favorable to A upon total number of equally likely cases. It's a classical definition for probability. It is really important, and please, most of the probability would go with this definition only. So what's the probability of happening of A? It is number of cases favorable to A upon total number of equally likely cases. Now please, this is really important. Total number of equally likely cases, right? And total number of equally likely cases, we call it a sample space as well. So we will talk about it. Don't worry, right? A sample space as well. So kindly make a note of it first, right? Probability of happening of A. We are going to talk about it now. Let's see. So, I say if number of cases favorable to event A are n, number of cases favorable to event A are n, and number of cases not favorable to event A are m. Alright, so I say number of cases favorable to event A, we take it as n, and number of cases not favorable to event A is m. In that case, probability of A would be n upon m plus n. Now listen to me, this is really important. N belongs to natural and m belongs to natural or whole. You can write whole numbers actually. Number of cases can be equal to 0 as well, isn't it? So probability of happening of event is n upon m plus n. And now I give you something really different. Probability of A bar is what? P of A bar is probability of non-happening. Probability of non-happening of A. probability of non-happening of A. So it would be number of cases not favorable to A upon total number of equally likely cases, which would be m upon m plus n. M upon m plus n. So guys, so if you take this as 1 and this as 2, so what is probability of A plus probability of non-happening of A? Just check out. N upon m plus n plus m upon m plus n comes out to be m plus n upon m plus n, which is equal to 1. So keep this thing in mind. Probability of non-happening of A is 1 minus probability of happening of A. Mark it important. Point number 1. Or maybe you can write it as point number 3, because 1 and 2 we have already defined. Or similarly, we also say probability of happening of A is 1 minus probability of non-happening of A. Mark it as 4. Mark it as 4, right? So in this context, guys, if you are clear with this, then I can easily sort out very important aspect. I say probability of A is n upon m plus n, where n comma m, they belong to whole numbers, which means probability of A is always greater than equal to 0, isn't it? Whole numbers. So every answer would actually be a positive answer. So probability is always positive, equal to 0, because n belongs to whole, so n can be equal to 0. And secondly, this probability of A can be n upon m plus n, can be written as m plus n minus m upon m plus n, which is m plus n upon m plus n minus m upon m plus n, which is 1 minus m upon m plus n, isn't it? So can I say that probability of event A is always less than equal to 1? See this, 1 minus something, isn't it? So today onwards, keep this thing in mind, that probability of any event lies between 0 to 1. So if probability of A is 1, it's called sure event, and if probability of A is 0, it's called impossible event. So keep these, this is really important, keep it in your mind so that you don't get confused. Probability lies between 0 to 1. So if you are getting an answer less than 0 or more than 1, there is something wrong. Alright, there is something wrong. So I hope this is clear. Then let me go to the classical definition again. See, we know this, isn't it? Probability of event is number of cases. You have read it. You have read it many a time. Number of cases favorable to A upon total number of equally likely cases. We call this, this in denominator as sample space. So if you are able to get a sample space, if you are comfortable with a sample space, most of your problems are sorted out. If you are comfortable with sample space. So let's see. I say, sample space when we throw two coins together. So what is a sample space when we throw two coins together? It would be, see, head head, head tail, tail head, tail tail. Sample space, total number of, so what is sample space exactly is total number of outcomes. Total number of outcomes, right? So please Just understand this. I throw 2 coins. So how many outcomes are there? Both the coins are showing head. One is showing head, another is showing tail. So here, this is your, you can mark it as, this is your first coin, second coin, first coin, second coin, first coin, second coin, first coin, second coin. I know many of you might be knowing it, but I know many of you might not be knowing it. So please clear this, clear this issue with the, so that you don't have a problem. So I say, what is sample space when 3 coins are thrown? What is the sample space when 3 coins are thrown? So now let's see. Head, tail, head, tail, tail, head. So, isn't it? So I introduced one head. Now let's see. Head, tail, tail, head. See? So 3 heads, 2 head, 1 head, and then no head. Tail. So how many elements this sample space has? It has 8 elements. And now you can otherwise also see, if I throw 3 dice, 3 coins, total number of outcomes would be 2 into 2 into 2. 8 outcomes. How many outcomes are there? 8 outcomes. And those 8 outcomes are this: 1, 2, 3, 4, 5, 6, 7, 8. And how to understand it? First coin, second coin, third coin. First, second, third. First, second, third. First, second, third, and so on. And so on. So I hope now you would get a good clarity, isn't it? A good clarity. Don't worry. Let's see. Possible outcomes when 2 dice are rolled. Possible outcomes when 2 dice are rolled. So total number of possible outcomes are 6 into 6, 36, isn't it? There would be 36 such outcomes. So total outcomes are 36. So what are those outcomes? Let's talk about it. Please see. So it is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. See, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And so on. So you can write 3, 1, 3, 2, and it goes on and on and on and on. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. See this? These are those 36 outcomes. These are those 36 outcomes. Isn't it? So if I say 3 dice are rolled, so total outcomes would be 6 into 6 into 6. 216. So how would it go to all the 2 dice outcomes? To all the 2 dice outcomes, just put 1 over here. Everywhere if you put 1, 1, 1, 1, 1, 1, isn't it? And 1, 1, 1, and so on. So 36 outcomes starting with 1, isn't it? Then put 2, 2, 2. So 2, 2, 2, 2, and then 36 outcomes with 2, 36 outcomes with 3, 36 outcomes with 4, and 36 outcomes with 5, and 36 outcomes with 6. So 6 into 36 comes out to be 216 outcomes. If you are comfortable with sample space, then only you would be very, very comfortable with probability as a whole, topic as a whole. So sample space. See, whenever we get a question on probability, we would always think, what is the sample space? Without that, we won't actually go around. So, for example, I say 2 dice are 2 die. I think you should not write dice. Dice is a plural. 2 die are thrown simultaneously. What is the probability that question number one, reading on both the die is same. Reading on both the die is same. Second, reading on die 1 is greater than that of die 2. Question number 3, I say sum of both the dice reading, it is dice, don't put die, dice. So sum on both the die reading is a multiple of 3. Sum of both the dice reading is a multiple of 3. Now this is a basic probability question, right? So now 3 dice are thrown, 2 dice are thrown simultaneously. First of all, this is a possible outcome. So I'm writing all possible outcomes now so that it is comfortable for you, right? Though I don't think you need to write the whole outcomes. You cannot write the whole outcomes when 3 dice are thrown. But just for the beginners, I am I am treating you as beginners, so that's the reason I'm writing it actually. 5-1, 5-2, 5-3, 5-4, 5-5, and 5-6. So question number one, he says both the dice show the same reading. So both the dice show the same reading. So guys, both the dice show the same reading. Here, see this: 1-1, 2-2, 3-3, 4-4, 5-5, and 6-6. So when you want probability, both the dice show the same reading. Total number of outcomes: 6 into 6, 36. The total outcomes 36, and the outcomes which are showing the same reading. So how many outcomes are showing the same reading, guys? These are those outcomes which are showing the same reading. 6 outcomes. So probability is 1/6. See, it becomes very, very easy if you have a basic simple concept of sample space, right? Again, question number 2, he says reading on dice 1 is greater than that of 2. So dice 1 reading is greater than that of dice 1 reading is greater than that of 2. So I can see this. See, I'm putting it in orange. 2-1, 3-1, 3-2, 4-1, 4-2, 4-3. So you don't even need to write it. I can see with 2 there is 1 reading, with 3 there is with 2 there is 1 reading, with 3 there are 2 readings, with 4 there are 3 readings, with 5 there are 4 readings, with 6 there are 5 readings. Just check out, I'm just showing it. See, with 5 there are 1, 2, 3, 4 readings. With 6 there are 1, 2, 3, 4, 5 readings. So upon total number of outcomes, 6 into 6. So kindly add it, comes out to be 6 plus 3, 15 by 36 is the probability. So cancel by 3, 5 by 12 is the probability. So you don't need to, genuinely you don't need that properly, that everything should be sorted out in a way that you have to write a sample space. You generally have to generalize it. Then he says, third question he says is, sum of both the dice reading is a multiple of 3. Sum of both the dice reading is a multiple of 3. So let me do it in yellow. So 1-3, 1-5, 2 cases. And then 2-1, 2-4, see, 3-3, 3-6. So every line has 2 possible cases. Just check out 4-2, 4-5, 5-1, 5-4, 6-3, 6-6. So total possible cases, every line has 2, so 12, isn't it? So your answer would be 12 by 36 comes out to be 1 by 3. So this is basic probability, right? Basic, simple, logical probability definition that you can always sort out, isn't it? So now let's see, what do they expect from permutation and combination? You should always know that. So I say, giving a very easy question, I say 4 cards are drawn. 4 cards are drawn from a pack of 52 cards. 4 cards are drawn from a pack of 52 cards, right? So find probability. Question number 1. All 4 cards are face cards. Question number 2. All 4 cards show the same number. Question number 3. All 4 cards are from the same suit. All 4 cards are from the same suit. Question 4. There is 1 card from each suit. Question 5. All 4 cards have same color. And question 6. There are 2 red cards and 2 black cards. There are 2 red cards and 2 black cards. Now this question is going to give you a real valuable aspect, so kindly make a note of it so that we can talk about it. Kindly make a note of it, please. Now, when we talk about cards, you should be very, very, because we have not been encouraged to play cards since our childhood in India. I understand it, isn't it? So, diamond and heart are red cards. And heart, they are red cards, right? Diamond is this, heart is this, red cards, right? And then club and spade. So I am writing it like this only. Club and spade are black cards. Club, we call it chidi. Just remember that. Yeah. Isn't it? We in Punjabi we call it chidi, and spade is hukam. So it's a it's a heart on this, isn't it? It's a inverted heart actually. I am just sorry, I'm not pretty good at drawing. I'm sorry again. I have to draw a heart over here, right? As okay. So just keep this thing in mind. So all those have 13 cards, 13 cards and 13 cards. Right? Now face cards again is important. Face cards, every suit would have, sorry, I've chosen a wrong pen. Every suit would have face cards as J, Q and K, Jack, Queen and King. Please, Ace, that is number 1, is not a face card. Alright, Jokers we are not considering because we are talking about 52 cards. So Jokers we are not considering. Alright, so Jack, Queen and King are your face cards. Alright. Now I don't know how many of you know there is a relation between a year and playing cards. See this cards and year. So how many playing cards are there? 52 cards. How many weeks are there? 52 weeks in a year. Clear? See the similarity. So how many seasons are there? Seasons. 4 seasons. Isn't it? There are 4 seasons. Summers, winters, autumns, isn't it? And how many suits are there? 4 suits. Isn't it? See the 4 suits. These are the 4 suits. Diamond and heart. Red suit. Club and spade. Isn't it? Black suits. Diamond, heart, club and spade. Alright? See the similarity? So each season is approximately how much? 13 weeks. Yes, just check out. 13 weeks. Each season is how much? 13 weeks. And each suit has how many cards? 13 cards each. Just for the sake of knowledge, guys, I hope you would absolutely like it, love it, So there is a similarity between playing cards and year. So obviously you can go to your parents and say, playing cards, they resemble a year, and maybe they allow you to play cards, because definitely there are a lot of questions in competitions that would come from cards. So let's talk about this now. The question that we were talking, just keep this thing in mind. Diamond, heart, club and spade, right? Diamond and heart, they are red cards, right? So now the question, 4 cards are drawn. Now listen, 4 cards are drawn. Now they are not drawn one by one, they are drawn, just picked up and drawn, just plugged out, isn't it? Plugged out. So what would be total number of, what would be in the denominator? See, any probability, what is in the denominator is really important. 4 cards are plugged. So total number of ways, 52C4. Equally likely cases. 4 cards from 52 cards. 52C4. You want an explanation? Please go back, just revise permutation and combinations once. So all 4 cards are face cards. So how many face cards are there? Each suit has 3. And there are 4 suits. So total 12 face cards. So 12C4 is, out of 12 face cards, 4 face cards are coming. So 12C4 upon 52C4. This is the answer for question number 1. Kindly mark it, guys. Clear? Good. Then question number 2. He says all 4 cards show the same number. So guys, listen, numbers are on what cards? How many cards have numbers? Ace does not have a number, Jack does not have a number, Queen does not have a number, King does not have a number. 4 cards don't have numbers. So other cards are, see, 2, 2, 2 and 2. Or 3, 3, 3 and 3. 4, 4, 4 and 4. 5, 5, 5 and 5. 6, 6, 6 and 6. 7, 7, 7 and 7. 8, 8, 8 and 8. For your convenience, I have to write 9, 9, 9 and 9 and 10, 10, 10 and 10. Otherwise, Ace does not have a number, Jack does not have a number, though we assume Jack to be 11 and Queen to be 12 and King to be 13. I agree, but they don't have a number written on them. So I won't consider them same number. So how many possible cases? 1, 2, 3, 4, 5, 6, 7, 8 and 9 cases. Alright. There are 9 such cases. So 4 cards show the same number. So out of 9 you have to pick one. 9C1 upon 52C4. 52C4 would be constant in all the questions, so hardly matters. 52C4. Out of these 9, one cases is picked up. If one case is picked up, obviously all 4 cards would be showing the same reading, right? Same number, right? Not the reading, same number. All right, clear? Then third. Third, all 4 cards are from the same suit, right? All 4 cards are from the same suit, either diamond or heart or club or spade. So all 4 cards are from diamond, 13C4. All 4 cards are from heart, 13C4. All 4 cards are from club, 13C4. All 4 cards are from spade, 13C4. Or, so see, either or, so obviously addition would come into play now. All 4 cards, right? Or has come upon 52C4. So it is 4 times 13C4 upon 52C4. See this? So easy. Clear? Then all 4 cards are from same suit, done. Third, then there is one card from each suit. One card from each suit. So most of the time people write, 13C1, 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 13C1. You cannot put a plus over here. Wrong. No. See? So one card from heart, 13C1, and one from diamond, and one from club, and one from spade upon 52C4. And the question is giving and ka sense. Each suit is having one card from each suit, right? So 4 cards have to be there. So definitely multiplication would be there. Alright? And then all 4 cards have all 4 cards have the same color. All 4 cards have the same color. We know that diamond and heart have red color, and club and spade has black color, right? So number of participants of diamond and heart would be 26. Club and spade would also be 26. So your answer is 26C4 plus 26C4 upon 52C4. Either all 4 cards are red, 26C4, or all 4 cards are black upon 52C4. Clear? Huh? So all 4 cards, or there is 4 cards from the same color. Then there is 2 red and 2 black. Again, fundamental principle of multiplication would come. So 26C2, 2 cards from red, and 26C2, 2 cards from black upon 52C4. So this is your 6th answer. With that, I hope there is a clarity what is the sample space. Whenever if you ask me, sir, how do you do your probability, we would always go for the sample space first, right? So please keep this thing in mind, and we will continue this to the next class. This was the basic of probability, basics. So see you next class, and we will do better than this, right? Thank you so much, guys. God bless you all. Take care. Thanks.